Good.
Hey everyone.
Hey everyone, good evening. GM. And we are back with another session. And this time we are going to help you into dive deep into the Ethereum ecosystem. So Hyperedge presents Winter of Blockchain is an open source contribution program for contributing to blockchain and related projects. And today we have two very special mentors from our server, that is the Winter of Blockchain server. We have Smit Sakariya and Rahul Kulkarni, who will be, giving you a very nice deep dive into Ethereum. So Smith will be presenting a nice introduction to Ethereum, and then followed by Rahul. Rahul will be, giving you the much needed hands-on exposure to Ethereum development. So yeah, here they are, Rahul and Smith.
Hey Rahul.
and and
Uh,
and
you're
and
on
and the
stage.
best part is yet to be revealed, so you'll have to stick till the end of the session. We have a surprise for you. Yes, it is another community project that we are going to be revealing, so you'll have to stay around till the session ends, and we will make the reveal after Rahul presents his hands-on session.
Cool. So, um, Smith, are you here? Is your microphone working?
Yeah,
Yeah, cool.
am I
Sure.
audible?
Yes, yes,
Yes, Smith,
yes.
you're audible.
Okay, yeah. So, can I start?
Yes, you can start. Smith will be giving a brief intro, right? He'll be giving an introduction on the Ethereum, and then Rahul will be doing a hands-on session on it. So for now, Smith, you have the stage, all right? And I'll be taking questions in the background. Cool.
Yeah,
All
sure.
right then.
So, is it visible? My screen is visible to everyone.
I've added it. Yes, you can go.
Hello,
It is visible. It is visible.
can you confirm?
Go ahead. Yes, yes, yes. It is visible.
Okay, yeah. So, good evening, guys, and welcome everyone. I'm thrilled to be here today to introduce you to the fascinating world of Ethereum blockchain. Whether you are new to the concept of blockchain or expert, I hope to provide you with valuable insight into this exciting and rapidly evolving technology. So here it is, the brief intro about me. Anytime you can reach me through my social accounts via LinkedIn or Twitter. So without further delay, let's start with today's session. So blockchain technology is recently like increasingly popular in recent years with numerous applications in various industries. And out of them, Ethereum is one of the most popular blockchain platforms, offering its unique features that distinguish it from other platforms like Bitcoin. So in this presentation, I will introduce you to the basic of Ethereum blockchain, covering its architecture, benefits, and limitation. So by the end of this presentation, you will have a better understanding of what Ethereum blockchain is, how it works, and how it can be used in different industries. So let's start. So you all are already know what is blockchain, but let's give me a quick refresher on how exactly it is. So by definition, blockchain is a distributed ledger technology that enable secure, transparent, and tamper-proof transactions, like fully distributed database like Bitcoin. And but the blockchain, it consists of a chain of blocks with each block containing a set of transactions that are verified by network nodes through the different consensus mechanisms. So once block is added to the chain, it cannot be modified or deleted. The main fundamental of the blockchain is this, like you can't modify or the delete it in any block or any time. Here you can see the advantages and disadvantages of the blockchain. So you can see the main disadvantages are like scaling and performance issue. But day by day, our open source community of the developer are working on that, and in nearby future, like this also scaling and performance issue may be resolved. So some of the history of the Ethereum, you all are know Vitalik Buterin, right? So Ethereum is revolutionary technology that has brought a lot of innovation to the blockchain industry, and it was co-founded by Vitalik Buterin, a Russian Canadian programmer who was like just 19 years old at the time, right? So here is some of the timeline of the Ethereum platform, how it's begin and till then how it's going on. So like Vitalik first got interested in blockchain technology in 2011 and went on to create Ethereum in 2013 and 14, and then rest will be the history. You all are so. So what is Ethereum? Ethereum is a blockchain platform that enables the creation of decentralized application and smart contracts. And you all are know native cryptocurrency of the Ethereum blockchain is Ether, which is used to pay transaction fees and incentivize network participants, which we know as a miners. So Ethereum blockchain has some unique characteristics that distinguish it from other blockchain platforms, such as its ability to support the complex smart contracts, execute code in decentralized manner, and facilitate the creation of new tokens and dApps on top of its network. Sorry. Ethereum has becoming one of the most popular blockchain platform with large community support of developer users and stakeholders. So we are in the right track. Let's start with Ethereum blockchain paradigm. So Ethereum blockchain is like essentially a transaction-based stats machines. You all are know in computer science like a POC subject theory of computational. So like what exactly it is? Like a state machine when referred to the something that will read a series of inputs and based on those inputs will transition to a new state. So like with Ethereum state machine, we begin with Genesis state and this analogous to a blank state, like before any transaction have happened on the network. So when transactions are executed, this Genesis state transitions into some final state, and at any point in time, this final state represents the current state of Ethereum, right? So the state of Ethereum has millions of transactions, but these transactions are grouped into blocks. And this block contains series of transactions, and this block is chained together with its previous blocks. So this way all our chain looks like in Ethereum blockchain. Right? So you can see Ethereum Block Explorer. This is the website of the Ethereum Block Explorer. Here, this website allows user to explore the Ethereum blockchain by viewing the blocks, transaction, and addresses on the network. These websites are commonly used to track the progress of the transaction, verify the status of the smart contracts, whether it is deployed or not, or in transition state and or not, and monitor the network activity. So they also provide user with valuable information such as gas fees, block times, and network hash rate, which can be used to make informed decision when so like which can be used to the make different decisions and interacting with Ethereum network. So this blockchain explorer looks like this. Okay. So here is the main part of our dApp architecture. How exactly Ethereum blockchain dApp architecture looks like and how exactly it's this. So Ethereum blockchain is composed of networks of nodes that communicate with each other through peer-to-peer protocol, and the nodes maintain a copy of blockchain and verify the transaction through the consensus mechanism, like proof of work, proof of stake, proof of history, etc., right? So Ethereum has its own virtual machine called Ethereum Virtual Machine, and which enables the execution of the world's smart contracts in decentralized, right? So, like, what is smart contract? So, smart contract are self-executing program that can automate the or business logic like contractual terms and condition between different parties, like without need to intermediaries. You can we have a hands-on session of the smart contract here after the introduction part is over. So here you can see this is the typical architecture of the complete depth on Ethereum blockchain, front end, back end, and blockchain. So what in our traditional Web2 architecture, where we use database, here instead of that, we have to use blockchain like Ethereum for providing the decentralized, right? So front end and back end works like what works in Web2, and the database replace the blockchain, and that will be connecting via the Web3.js and Ether.js. There are so many different libraries and frameworks available for connecting blockchain to the front end. So you can see that. So this is what our DApp architecture looks like. Here is some of the advantages and of the Ethereum blockchain, like decentralization. So talking about decentralization, like which decentralized means that there is no central authority controlling the network, and this make it more resilient to the censorship and single points of failure, right? Programmability, like any developer can create smart contract that can automate various function and execute code in decentralized manner. Interoperability is one of the like most fascinating words nowadays for the particular the blockchains, right? So Ethereum blockchain supports interoperability with other blockchain platforms, which means which enables the transfer of value and data across different networks. Like you want to communicate with other blockchains, so like through the interoperability, it is possible somehow. So here in parallel blockchain side, there is like another concept like new bridging system which will be communicating through the different blockchain, and it's like in nearby future 2 3 years you know all those things how exactly this cross chain work. So tokenization and transparency, security, all those things. So here some of the limitation of Ethereum blockchain is also, which we also already talk about, like scalability. So scalability is main issue, which means that it can only handle limited number of transactions per seconds, and this can lead to delays and high fees during the times of high network activity. You can see the gas fee of the Ethereum blockchain is very high due to the scalability issue is there. But recently they are coming with new 445 EIP system, which solve the the logic of that EIP is like distributing the different shards and doing that more scalable network to the system. So in that way, we can reduce the gas fee of the Ethereum blockchain system. Also, after the Ethereum 2.0 is coming, like proof of stake consensus algorithm. So there are many progress happening side by side, and these limitations nearby future mostly it's resolves. One of the energy consumption is issue which we already solved through the proof of stake transition from Ethereum 1.0 to 2.0. Governance is like one of the main issue right now. Some government are ready to the accept to the blockchain and some are not. But it's like internal parts. You can do anything about governance. Smart contract vulnerabilities. There are some of the like hacks, and there are many blockchain other than Ethereum blockchain. But why Ethereum still one of the best blockchain is because of their proof of work and proof of stake algorithm. Like other blockchain is like popular in some of the part, but when security and vulnerability is coming, they all are failing. And one and only Ethereum, till now, Ethereum is leading all blockchain ecosystem. So here is some of the ERC standards you may familiar or no, I don't know. But ERC means Ethereum request for comments. Like the ERC is like a set of technical standards we use for any smart contracts on the Ethereum blockchain. And like ERC tokens and are digital assets that can be managed by the smart contracts and follow the specific set of rules defined by the ERC standards. So ERC20 is one of the most popular standard for the token creation on top of blockchain, on top of Ethereum blockchain. And while other standards like ERC 721, 1155 are used for the non-fungible tokens, NFTs, and these standards are ensured interoperability between different dApps and wallets. And like it's making easier life for the developer to create and user to interact with wild range of tokens and all the stuff. So, okay. So let's talk about different types of blockchain. So there are four main types of blockchain networks: public, hybrid, private, and consortium. So in public blockchain like Bitcoin and Ethereum, there are totally decentralized network that anyone can participate in while, right? But in while private blockchain that are permission network that are only accessible to the authorized parties. While hybrid blockchain is combined feature of both public and private blockchain, right? And in consortium blockchain that are controlled by a group of organizations that work together to maintain the network. So each type of blockchain has its own unique strength and weakness, and the choice of which to use is depend on the specific use case and requirements of the network. Like what's your use case and what's your problem statement. On that we select the types of blockchain, but mostly public blockchain is recommended because of the decentralizations and all the stuff. Right? So let's talk about one interesting stuff here. How exactly side chain works? Like the Polygon, and recently the Polygon is like one of the center point for all the blockchain. So how exactly reduce that gas fees and transaction fees, and how side chain connect with main blockchain, right? So here are the architecture of sidechain. Like it's typical design to the operating in parallel with the main blockchain. So the sidechain has its own set of nodes that validate and process transaction on the chain, and these nodes are connected to the main chain through a two-way peg. This two-way peg is essentially a smart contract that lockups assets on the main chain, and this is exchanged for a corresponding amount of asset on the side chain, right? So this create a bridge between the two chain from main chain and parallelly side chain is working. So the side chains is like its rules and consensus mechanism may differ from the main chain to enable specific use cases. Like, for example, if the main blockchain is consists of Ethereum blockchain, Ethereum 1.0, like proof of work consensus, and there may chances like sidechain is working for the different consensus mechanism. It's not any issue like that. So, like Polygon use proof of stake, a consensus algorithm. So it's working. There are no issue about consensus algorithm and all those things. So in this way, we can reduce the exact gas fee which on the main blockchain Ethereum 1.0 is taking, and sidechain reduce all this gas fees. So in here in this diagram, you know exactly how it's working. So chain one is like our Ethereum. 1.0, and chain 2 is like a polygon. So what happened? In Polygon blockchain, every transaction record with like a group of transaction made, and that group of transaction consists one block. After that, second block added, third block added, fourth block added. So there are many transactions included in these four blocks, right? And the combine of these four blocks, one transaction we make, and that one transaction go to the main blockchain as a single transaction. And this whole methodology is providing by there are one layer smart contract which working with sidechain and main chain respectively. Right? So this way ma- we reduce major gas fees. Like in one transaction, like for example, on Ethereum, for one transaction, you have to pay 1 Ether. So here what happened? Here block one consists 10 transaction, block two 10 transaction, three, four. So 40 transaction of making one single transaction. So for we divide by 1 Ether by 40. So we drastically reduce the whole gas fee of the main blockchain. So in this way, side chain very helpful in reducing the gas fees. So let's talk about one interesting stuff. Yeah, what is hard fork and soft fork of the blockchain? If you want to like build exactly the another blockchain like Ethereum blockchain, you want to a hard fork and soft fork. So this may be helpful for this. So like fundamentally, fork is change to the rules of blockchain protocols, and it can be anything like hard or soft, right? So in hard fork is a permanent languages from the previous version of the blockchain, like where the nodes that do not upgrade to the new rules, but only validate the new blocks. Like this means that old and new version of the blockchain will become incompatible with each other. There are no any communication between old version and the new version. Like for the example, hard fork. Let's give one example for the better understanding. For the like the Bitcoin case. Like so, what happened in 2017? There is like a fork happening from the Bitcoin blockchain, and that fork known as a Bitcoin case after. And this will be through the hard forking. Like what happened? Hard fork is occurring due to the disagreement among the Bitcoin community. Like some want the block size limit increase, some increasing the block size limit to the like I think 8 MB to improving like transaction speed and reducing fees. So for that Bitcoin community, some are agree with this new blockchain, new block size and increasing the transaction level, but some are not satisfied with this. So what we do, we create the hard fork from the Bitcoin blockchain, and we create we give the another name Bitcoin Cash, and that will be our new version, improved version of the block size and transaction limit. But old Bitcoin is working as it is. So there are no clash from old version and new version. But in soft fork, what happened? That will be a backward compatible change to the blockchain protocol. Like when nodes that have not upgraded to the new rules can still validate new blocks. This means that the old and new version of the blockchain can still communicate with each other. Like for the example of the soft fork is SegWit Witness. I think you know or not confirm. But it's upgrading to the Bitcoin protocol, and this will be the more transaction to be proceed with each block, like without requiring hard forking. So like if in previous example, if the whole Bitcoin community agree with same block size and transaction space, so what we are doing? Simply soft forking. Like we are forking that things, improving changes, and we push in main chain. So all in one new version is like totally new version. We upgrading in that. So this way, soft work will work. Okay. Yeah, so that's it from my side. Here is some of the references to the learn blockchain because we have another hands-on session after that. So let's start if you have any question.
So that was an amazing session, Smith. So now we will be having do you have any questions, people? Like, if you have any, you can drop it on the chat and we'll take it up. Meanwhile, we'll be calling Rahul up here and he will be giving a hands-on session. So, Rahul, you're up.
Hey, GM people, how's it going? Hope you are having good time here. So today we are going to take our hands dirty and building on Ethereum. So we will start with our wallet setup. So yeah, let's start. Let me share my screen. Okay. Is my screen visible?
Yes, I've added it.
Yeah, it is visible.
Okay. So I guess you all have this notion. The notion will have all the content related to the today's workshop. So first of all, let me just give introduction to myself. I'm Rahul Kulkarni. I'm Flutter and blockchain developer, and I'm currently working as a software developer in a startup based in Pune. And I am also a contributor at Super Team DAO, mentor at here Hyperedge, and I am a lead at Polygon Guild Vadodara. So yeah, feel free to connect with me on Twitter, DM me if you have any queries, and yeah, we'll talk about that. So for this session, let's start with setting up our MetaMask wallet. So what is MetaMask? First of all, so MetaMask is a wallet for the Ethereum blockchain. It is a non-custodial, meaning that the private keys of your wallet will be held by you yourself. MetaMask will not store any kind of private keys or the seed phrases to its server. So yeah, you will have the control of your wallet. So yeah, let's install it first. So I have provided the links here. So just click here, so you will get to the MetaMask Chrome extension web. So yeah, just go here and click on add to your
We
browser.
we also had the MetaMask thing added last day in our last session, so some of them might have it already. So, yeah.
So till it's installing, also load up the here. When our installation is complete, we have to get our testnet inside our MetaMask wallet. So what we can do is just go over this website. It's called Chain List Organization. They provide various yeah, just go there till this where developers stage their programs, their codes, and everything about the so MetaMask is installed. We have to create our wallet. So just open MetaMask. Okay. Select here to create wallet. I have previously created a wallet, so your wallet with the seed phrase. So for our case, we will create a new wallet. Here, click on I agree. Set the password for your wallet. So it can be anything. So I'm creating this wallet for just for the demo purpose. So make sure you have the strong password for your MetaMask wallet. So once you set the password, you will have this screen where you have to secure your wallet. So just secure your wallet. This is the seed phrase. So as I said earlier, MetaMask is non-custodial wallet. So the user will have the control of their wallet. So for this, so whenever in future you have to log in again from some other devices, you need this seed phrase to fetch all your accounts or all your wallet addresses. So for that, you have to make sure you save this and secure your seed phrases. Just have secure this seed phrase. It is a 12 word, it can be or 24 words. So make sure you save this seed phrase, because this seed phrase will be useful when you will try to log in again from some other devices. So at that moment this seed phrase will be required. So make sure you save this on some secured manner. Okay, so after that we'll say next. So this is the part where you have to enter the seed phrase, some parts of it. So just take it from here. Confirm. Got it. So our wallet is created here. As you can see, we have our brand new wallet created here, but we don't have any funds, and this is currently says that we are on the mainnet. So what we can do is we can add, as you can see here, it is Ethereum mainnet, and we don't have any other network. We can add other network by manually, but we will use the chain list. It makes our work super easy. So just include the testnet here. So check here. Let's just refresh it. So here, as you can see, we have Ethereum mainnet, we have Binance Smart Chain mainnet, we have Polygon mainnet. So these are all the different mainnet available for EVMs, and you can add that to the your wallet. So for our case, we are using MetaMask. You can have some other wallets also. So we will just ping our MetaMask here, connect wallet. So once you connect wallet, so every time you make any transaction or any connection using MetaMask to your app or any application, you have to connect your wallet first. Think of it as a sign-in procedure. So for Web2, you use login and you use username and password. For Web3, you will use the MetaMask or any other wallet to connect your wallet to the application and to make any transaction on the blockchain. So let's just connect wallet here. Let's go. So it's connected. So we will use the Mumbai testnet. It is Polygon testnet. So yeah, add to the MetaMask. So this is the chain ID, this is the currency, this is the Mumbai testnet. You can add this with manually also, but yeah, we will use the add MetaMask option here, and it will add. You can see the all the details here: the network name, network URL, chain ID, currency symbol. So yeah, we'll approve the transaction, switch network. Now when you go back to your MetaMask, you will see there is a new chain or new network added to your MetaMask wallet. As you see here, Mumbai, we have now Mumbai network. We'll also have Ethereum mainnet, but we will work on Mumbai network. So yeah, this is how the networks work for the MetaMask. You can add as many networks as you want, and this is the one chain list is the one platform where you will find the different networks. So once the network is added, we'll need some funds to make any transaction, because as you can see now, we don't have any funds in our MetaMask. Uh, it says zero matic, zero. Okay, so just copy your account, your wallet address from here, and I have given the link to the faucet. So to add funds to your account, just visit this faucet. It's a Mumbai faucet, where you will find the test tokens, which will be used to make transaction on test the network. You cannot use it on the main network, obviously, but for development purpose, we can use them on the test network. So paste your wallet address here. Once you paste it, just submit and confirm your request. It will take a couple of minutes to make a transaction to your address. uh, Request in progress. Request submitted, the transfer is on the way, and token will transfer to you in 1 to 2 minutes. So as I said it will take a couple of minutes. So let's just check our wallet. You can follow this tutorial with setting up MetaMask. You will have all the links required. You can install MetaMask from here, you can set up your wallet, MetaMask from here, and lastly add the funds to your account. So just check whether the funds are arrived or not. So as you can see here, we have the test funds in our Mumbai test network. So 0.2 matic, we will use these test funds to test tokens to make transaction or our deploy our contract on the blockchain. So yeah, I have also given the links to some resources where you can start your blockchain development. So we'll start our hands-on session now. So first of all, what is Solidity? So Solidity is a high-level programming language which executes the smart contracts on the blockchain, Ethereum blockchain, basically. So any EVM compatible chains, they use smart contracts, or they use Solidity as their programming language to write the smart contracts, which can be execute on the Ethereum blockchain. And this is the basic some keywords which we'll be using in our contract. So I will go through them. So what is the contract? So contract is the keyword. Think of it as like the classes you have in Java or C++. So when you think a class, you can have the functions, you can have the objects, you can have variables. So it is similar to the classes of JavaScript, but the contract keyword specifies that this contract will be executable on the blockchain. So as you can see, keyword is used to define a new contract, which is collection of related functions and data that can be deployed on the blockchain. After that, we have the constructor. So yeah, constructor is a special function that initialize the state variable. So what is the state variable here? So every variable which is going to store its value on the blockchain is called the state variable. So in our contract, so first of all, I will just introduce the smart contract version 0, which is just having your name, and we'll set our name using the constructor, and we'll return our name using this function. So as you can see here, I have given all the details. So Pragma Solidity is the version of the Solidity language or the compiler we are going to use for our this contract. Then contract name contract is just like class, and give the name of your class in Java or in JavaScript. So contract is the keyword which is going to execute on the blockchain. Name contract is the name of our contract, and after that we have this variable called name. Constructor will basically, what will it do is it will just initialize the value whenever this contract is compiled. The initial value of this variable is set to the hello world, and yeah, it will be done by the constructor basically just initialize the value of your variables whenever your whenever your contract is compiled. So after that we have this function called get name, and it will just return the name of our variable. So in our case, it should return hello world. So you can just copy this code from here. And yeah, so how we gonna test this how are we gonna test this code, right? So for that we are going to use Remix. So Remix is the online ID where you can test or deploy your smart contracts on EVM. So it is basically online ID, so you don't have to make any installation on your local machine. You can just use it online, and you can make your smart contracts, you can test it out, you can play with your contracts. So yeah, we'll just create a new file here. For our case, we'll say hello world. So I already have one, but yeah, let's just copy. So if I save this, and you can compile this code basically by saving it also. So just control S. So as you can see, it is giving me error. So yeah, so here it should have comma, semicolons. Okay. And yeah, so basically note one thing here: you have to set your compiler version similar to what is the language of version of solidity you are using. So you can change it from this compiler version here. So right now we are using 8.0. You can write latest, you can see here latest version is 8.19, so you can change it accordingly. Yeah, we will use 8.0 for now. Compile your code from here. Yeah, we are ready to go. So as you can see here, Remix gave us this 10 test accounts or 15 test accounts. We can use them, and we can also use their funds. As you can see here, we have 100 ethers, which is our test tokens, obviously. For our workshop, we have installed the Metamask, we have set up everything, so we will just use Metamask. So go from here your environment, select injected provider. Okay, so you have to unlock your injected provider. Metamask. Sometimes it takes some time to load Metamask. It is very slow. Okay, so we have our Metamask here. We just connect to the injected provider. It is unlocked. Okay, just select our file here, hello world 1.sol. Compile it. Okay, so you can also do this on some other network. Let me just share my screen. Okay, so here we go. Just your make sure you have some tokens in your wallet on Mumbai Test Network. So I guess that profile have some issue because of I tried it earlier. Okay, go to your contract here. Okay, compile it. Make sure contract. Okay. Select your account, make sure you are on the test network and connect. Okay. So as you can see, our wallet is connected. Here is the wallet address, and here is the test tokens that we have in our wallet. So once you have compiled your contract, just go over here. We'll have the button of the deploy. Just click on the deploy. We have to sign the transaction so that the contract gets deployed on the blockchain. After you sign this message, make the transaction confirm. Look out for the contract address here. So as you can see, our transaction is completed, and here is the status. It is minted and execution of the transaction is succeeded. So I'll just copy the contract address to check it on the our explorer. So as Smith earlier explained that we have this block explorers. So for Mumbai, we have Mumbai block explorer. Just go to the Mumbai explorer. So here, as you can, testnet polygon blockchain explorer. Click on it. Copy your contract address from here, and you can check the status of your contract, and you can check the block hash, block number, transaction hash, everything from this. So just paste your uh, contact address here. So as you can see, uh, make sure you copy it. Yeah. So yeah, as you can see here, 1 minute ago, we have made this transaction contract creation. This is the transaction hash, this is the method, this is the block number. So basically block number is how many block the blockchain has and which block has your contract. So this is the number of your block which contains this transaction of the creation of the contract. So this is basically overview how you can use the explorer. You can check whether your wallet has how many funds, which wallet had. You can just copy the wallet address here. You can check the wallet address and the funds that wallet contains, and you can also check the whether different tokens that a particular wallet contains. So yeah, this is how you can use any explorer. After that, so what now, we have just deployed our contract. So as you can see, we are just having this one function here, which is return, which is the return statement, and it is returning the name of our variable. So we'll just get name here. It will return our hello world name to us. So as you can see, but it is just like it is a constant value. What if I want to change the name of this variable? So if you go to the notion that I provided to you, you will find another contract which is a this hello world. Yeah. So this one has two functions. One is set name, one is get name. So just save this contract, and yeah, deploy. Sign the transaction. So every time you make any transaction on blockchain, you have to sign the message, because as I said, it is permissionless. So you have to make every transaction by your side. You have to sign every transaction that you are making this transaction. So I'll just confirm the transaction, and yeah, once the transaction is done and the contract is, so currently it is in the pending status. So once it's done, we will get two contract. Yeah. So here, as you can see, we have now two functions. One is for set name, one is for get name. So for getting any information from blockchain, for fetching any information from blockchain, for reading anything from the blockchain, you don't have to pay anything. You don't have to sign the transactions as well. So yeah, we'll just get name here. So as you can see, our name currently has constructor, and it is setting our value of the name variable to the hello world. So let's just change the name here. Let's say Rahul. Set name. So as I said, making any transaction, writing anything on the blockchain will need to sign the transaction and to pay gas fees to make any transaction on the blockchain. So basically, this gas fee is for is the validators get. So when validators validate the blockchain, they get some rewards, and these rewards are in terms of this gas fee tokens. So as you can see, we have to pay gas. So this much matic token we have to pay in the gas. So this gas for some portion of this gas fees goes to the validator to validate this transaction. So when the validator makes this transaction validate it, the validator will have some of this amount as the reward. So I'll just confirm name contract and the set name is pending, as you can see here. So it is setting. Okay, it's confirmed. So I'll just get name. Now the name should be changed to the Rahul. So as you can see here, name is changed to the Rahul. So this is how the basically you can get your name and you can set the name. So all of these data types I have shared it in the Notion. You can check it out on the Notion. So what is the public, what is the private? So public is basically it can be accessed from the outside of the contract as well as within the contract. So this is the visibility of your variables or the functions. You can mark them as public. So public will be available from if you for example, you have three contracts, you can use public keywords in one contract and you can use the same variable. You can access that variable from another contract as well. And for private, you can only use it by the access from within the same contract and not from outside or within derived contracts. So you cannot access it from the different contract. You can just access it from the same contract here. After that, we have internal, we have external. The internal is can be accessed from within the same contract or any derived contracts as well. And external can have functions can only be called from outside the contract. It cannot be accessed from within the same contract. So yeah, this is the version one of the smart contract, which we'll just check. Yeah, so this is the one we just saw earlier, which is like set name and get name. So you will find this all the examples on the Notion. After that, we will see how the CRUD operation works on the blockchain. So we are getting a bit late here, so no worries, we will complete it in 10 to 15 minutes. So yeah, so this is the to-do list on chain. So this document explains how the to-do list works on the Ethereum blockchain. And yeah, we will start with this contract. So you can just copy this code from here and paste it over the remix, which is Ethereum ID, as I explained earlier. So I'll just go through the code. So what is the struct here? So struct is a way to create a new data type that is a representation of composite of other data type. So struct is a user defined data type where you can have different different types of data types, and you can composite them inside one single data type. So as you can see, we have unit, we have this id which is a data type of unsigned integer. We have the content which is a string. We have completed mark which is a boolean. And after that, we are having one mapping here. So what mapping this does is it takes a key pair value, and it has the unique identifiers, and the values can have the any data type. So in our case, we are having this task structure, and we are mapping it with the integer. So it will take it will tell us how many tasks have been added to this structure. So yeah, after that we have some events. So basically events are on the on blockchain. We can emit these events, and you can read what the transaction has changed inside this particular contract. So for that we use emit, and also we can check this from our dApp also. So if any event has occurred, we can just check that this event is occurred, and it will return these types of variables, or as you can say values So we can check if the task is created and what is the content of the task. The task created event is emitted. We will get the values of this particular event. After that, we have updated event, which works as the same. After that, we have task removed. So yeah, this is how we will use the CRUD operation. We have to create, we have to update, we can read, and we can delete, as the CRUD operation says. Sorry for that. Yeah, so as I said earlier, constructor will create a it will initialize the value of our any function or a variable. So for here, as you can see, create task, which is a function, and it is taking one argument as a memory string content. The data type is string. Memory keyword basically takes the value between the functions, and not this will not upload the value to the blockchain, but it will only pass the value from the one function to another. So yeah, so we are initializing the value of our create task function here to the example task. And yeah, so this is these are all the functions how we can create a task. So we have made one task count variable, as you can see here, which is initialized to 0. And after every task is created, we are increasing the value of this task count variable. And after that, we have task structure. So index of this task will be this task count, which is incremented by 1. So for this case, it will be 1. After that, task structure, which is taking three values, which will be a task counter, then content, and then it is completed or not boolean variable. So for this case, we are assigning the value to the false. And after that, we are emitting the event here, as you can see, which we created earlier, task created. So this can be read through the depths, or this can be also read through the block explorer also. You can check the value of this event on the block explorer also. So after that, we are emitting the event, and we are assigning the values here, like task count, which is the index of the task created. After that, we are having content, which will be a string format, and we are assigning the false to the task completed boolean. Same goes to the get task. So for after we create task, we will get we have this another function called get task, which will return the value of the task till we have created till now. So as you see here, we are having this task array, which is from memory, and task is the name of the variable. And here, as you can see, the task count will be the length of this task. After that, we are having this loop here, which will be run through this I is equal to 1 to the task count. The task count is a variable which will be incremented every time we add any new task. So it will go till the end index of the task count variable, and it will just assign the value of this task's structure, and it will take index of I minus 1 because we are using array, and it will assign the value to the task structure. And after that, it will return this array of the tasks. Okay. Yeah, after that, we have update task. So once we create any task, we can update the particular task by the ID of the task. So for the update task function, we have two arguments: what will be the content of the updated task, and what is the ID that you want to update of the particular task. So we'll take this ID, we will fetch the current content of that particular ID, and after that, we will assign our value to this particular task, and we will emit the function, yeah, emit the event called task updated, which will have the ID which is passed by the user. It will have the content, and it will have the task dot completed, which means it is completed. It will pass that as a true. And for the remove task, it is basically simple. We'll just pass the ID, and it will delete the task from the tasks list, and it will emit this event. So yeah, one more thing, anything we have written to the blockchain cannot be deleted. So this will only delete the value from our task list or our smart contract, but the value is returned to the blockchain, and it cannot be reverted. So note that value returned to the blockchain can never be deleted. So yeah, this is how the whole function will look like once you have one by one look after the one by one functions. So just copy this function from this contract from here, to do list, go over to the remix IDE. So I guess I already have one. Yeah, crud.sol. Compile your contract here. You can do this by saving the file or just compile the crud.sol here. Yep. And make sure you are connected to the injected provider. So currently we have two deployed contracts, which is the one simple name contract, and after that we have one for the set name and get name. So now we will have our third contract, which is a to-do list. Just deploy this contract, sign the transaction to deploy our contract to the blockchain. Confirm this transaction here. Wait for the to-do list to create. Yeah. So as you can see, our transaction is completed. So here, if you go inside your to-do list, so we have three functions here. As you can see, one is create task, one is remove task, one is update the task, one will be get tasks, which will return all the tasks created till now. This is the task count. We have made it public, so you can access it from here. So currently it will only have one. Why it will have one? Because on the constructor we have created one task, and whenever we create a task, we are increasing the value of our task counter variable. So value of our counter will be 1. If I get tasks, as you can see, example task, I'm getting one value and it is example task. So I will just create another one. I will say wake up early. This is my task. I have to wake up early. Just transact, sign the transaction. So once you sign this transaction, our new content will be added to our list. So as you can see, uh, it is currently in pending state. Yeah, so it is created. So if I now check the value of my task counter variable, it will be increased to the 2. And if I get my tasks, it will have 2. One is wake up early, one is example task. So now let's just update the task. So for our here, as you can see, the value of our index will be 2 and wake up late. Sign the transaction. This will update the value of this content to the wake up early. So it will change the value to the wake up late. So just sign the transaction. Yep. So here just sign that, confirm the transaction. Update task is pending right now. Done. So we have changed the value to the wake up late. So now if I get the tasks, as you can see, the value to the wake up early is changed to the wake up late. So this is how the CRUD will work on the blockchain. So yeah, we can check the delete one also. So here just pass the value of your index. So it is currently 2. Sign the transaction. So for making any transaction, as I said, will need some test tokens. And if you check, we are getting 0.2 meta from faucet. But if you check the gas fees and the total amount of the, it is way less to as compared to what we are getting from the faucet. So you can easily deploy like 100 or 200 smart contracts from the faucet, the amount of you are getting from the faucet. So just confirm this transaction. Remove task is pending. Yep, it is done. So if I now get the count, it will be 1. Okay, let's just get the tasks. Okay, so as you can see here, we are getting only example task. So I guess I have not decrease the value of. Okay, so we have to decrease the value of the task counter variable here whenever we remove any task from the list. So yeah, that's one pending. So after that you can check the value will be decreased by 1. So after you change every time you make any changes to your smart contract, you have to redeploy it. So make sure you write your smart contract, and after your final version of your contract, so make sure you use the final version, because for the development purpose we can use as many contract as we can, but for the main net, or if you are going to deploy it on the main network, so make sure you use it on the final version of your smart contract. So yeah, basically that's it. We have all for this session. You can find all the required functions or required resources for this workshop on this notion. So make sure you have this notion. I have shared it with the Suvranil, so he will share it with you. And yeah, lastly we have
And
this
also, yes,
abi.json
I'll
file.
put that on. I'll put that on the Discord.
So whenever you
The
compile
Notion
any
file, yes,
or
given.
deploy,
Yes, sorry,
yeah,
Rahul.
okay,
I'm just saying that the Notion you have given, I'll provide that on Discord. You can continue.
okay. So yeah, I will just take 2 minutes. I will explain what ABI is. So ABI is basically application binary interface. So we use this to make a integration or contract connection from our DApp or our front end applications. So you will use this abi.json file whenever you want to make interaction with your smart contract through your front end web application or mobile application. You will use this ABI. This will have all the function and the variable required for your smart contract communication. And yeah, so that is the purpose of this api.json. We will also need the smart contract address. So make sure whenever you deploy your smart contract, you will get your contract address, and you will find it over here. You can just copy and use them. Yeah, so this is all we have for this session. Thank you for having me. Yep, thank you.
Awesome, insightful session, Rahul. Um,
Thank you so much,
Rebecca.
Rahul.
Yes.
Thank you.
Yeah.
So, people, we have some announcement to make, like Rebecca was saying. So, Rebecca, would you like to start, like, add something?
Yeah, obviously, we have to give them the announcement. We already announced at the start of the session.
So I'm sure many of you are excited for the project, since we have only had bootstrap session yet, right? So, and like we said, we'll be having two sessions with two communities this week itself, right? This week and weekend.
We'll
So
wait.
thereby
I
you'll
need the
be
drum rolls first.
what what.
Let's do it in a traditional way.
No,
Let's
no,
do it.
definitely. But yes, Rebecca will be like disclosing like which organization it is. But nevertheless, we have some more projects for you, and so Rebecca will be like telling you about them right now, and we'll be having sessions for them. So drum rolls.
Yeah, the drum roll. And our next project is project related to STEM. So yes, guys, you have heard it right. We are getting Lumos Labs on board, and they have their GitHub repo all set for you guys to explore and contribute to. So tomorrow 8 p.m. we'll be having a session with them, and get ready. Like they'll be talking all about what their project is all about and how you can add value to it. So that's all for now. It's already like past one
So
hour
yep,
and 9 minutes.
yes, our session was a little extended, since we have had two awesome speakers today instead of one like we have yesterday, like every day, every every day. But anyway, so the next session we'll be having with will be with Lumos Labs, like Rebecca said, and they will be do attend it, because they'll be sharing insights as to what you need to have prerequisites, or what you know how you'll be able to contribute to those projects. So yep, that's about it. That's about the announcements. We'll post the link to the next session on the Discord server, and definitely all the resources for today, I'll be posting them on the Tech Resources channel. um, okay, so we have
So
some
yeah, guys,
enthusiasm in the chat. Yes, sure. Cool then.
that's it
Rebecca.
for now. That's it
Yes.
for now, and we'll see you all again at the Lumos introductory session. So yeah.
So goodbye, Rahul. Goodbye, everyone. Thanks for staying with us. And All right then, keep contributing.
Keep contributing,
Bye.
guys.